nearly finished. We are just about at the end of our talking about these ranked voting systems. There are two more systems that I want to discuss. On the list, they are number 11 and 12, but actually they're both very simple, and so we should get through them today and then move on to something completely different. So, two more of these ranked style voting systems, although the second one is not exactly ranked. But actually, these two, like I said, are very simple to understand. I kind of like both of them, and I like using them in real life for certain situations. The first one, it sounds ridiculous, but actually the more this is one of those things that sounds totally stupid, but then the more you think about it, it's like, oh yeah, I kind of like that. This is called, and it even sounds like, even the name of it sounds stupid, random dictator. The random dictator method, all right? And I will describe how this works. So it's just like all of our other system. Everybody, votes their preference. Although because of the way it works, actually the rankings don't matter. It's kind of like plurality in that all that you care about is the top choice. But anyway, here's how you do it. One ballot is chosen at random. This method, by the way, is also called the random ballot method. It's the same thing. One ballot is chosen at random, and then that choice, well, I'll say it's a little confusing. The choice on that ballot, the first place, I keep on erasing. The first place choice on that ballot becomes the winner. This is the random dictator method or the random ballot method. So it's like, we could do this right now. I didn't plan a cute little activity, but we could if we want. I could ask you all to vote. All of you write your vote on a little piece of paper. Could be, Trump versus Harris or something. And then you give them to me. Now, ordinarily, you would count up the votes and see who got more. But this is different. This method, you would just put them all in a bucket or something and choose one at random, and that determines the winner. This is called the random dictator method, or the random ballot. I think random ballot is probably a better name for it. The random dictator means, the reason for that phraseology is it's as if I pull that one ballot out, and then that person, whoever casts that ballot, becomes a dictator. Their opinion determines the outcome. All right? This is the random dictator method. Now, this sounds crazy to me just because if you're doing some kind of important decision making, I feel like you probably shouldn't leave it up to chance in this way. This kind of randomness is a little uncomfortable to use in real life. But from kind of a mathematical point of view, this is actually a pretty great system. I would say, for example, if let's say 75% of the people vote a certain way, then they win 75% of the time, right? This is like a system that's based on, if you think of it in terms of probabilities, it works perfectly. If a certain proportion of the voters feel a certain way, then that proportion will win in the appropriate proportion, right? If 75% of the people vote a certain way, then they will win 75% of the time. That is, if you're doing this over and over again. The only way that these probabilities really work in practice is if you're somehow doing an election over and over again. So if you're doing it once, it's really just up to chance. You won't realize what the probability is if you do it only once. But if you're doing it over and over again, over time, this becomes a very fair system, I would say. So if you do it just like any kind of random things, if you do it only once or twice, then it can be fairly unpredictable. But over many, if we do this over and over again, if we do it a lot, then each individual one may go this way or that way, but over time, in the grand scheme of things, it will end up being extremely sort of fair and accurate to the people's preferences. So if we do it a lot, then it eventually matches people's opinions very well. And this actually is, in this sense, much better than most of the other systems that we have discussed. Like, consider if I'm going to make a decision, say 1,000 times, you could do every time count up all the votes and see who wins, or you could do it in this sort of random way. Think about it this way. If you're doing an election like this, this will be very different if you, for instance, use the plurality system every time. So in the random dictator system, or the random ballot system, if 75% of the people vote a certain way, then they will win 75% of the time. But in a normal, like, non-random system, in a non-random system, let's say the plurality, just as an example. The plurality is like, the ordinary way that we usually vote. If 75% of the voters, I'm going to try and say the same thing. If 75% of the people vote a certain way, then they will win. Anyone want to fill in the blank? Something percent of the time. This is actually, if you're using plurality, it's very different. In the when you do this randomly, you get sort of like equal proportions. Can anybody say what will happen here if you're doing a more traditional election where you actually count up the votes and you just see who wins every time, and 75% of the voters vote a certain way? How often will they get their way in terms of the results? This is kind of like, we could imagine doing this right now. If 3/4 of you, if I ask you, like, what's better, lunch or dinner? If 3/4 of you prefer lunch, and we just vote over and over again, what's going to happen? I think the lunch will win every time, right? So the fill in the blank here is 100% of the time. If 75% of the voters vote a certain way, they will win 100% of the time. That's because they're just going to win every time. If you actually count up the votes, those 75% will win every time. This is different from a random system. And I would say this is kind of less fair this way, right? The people, if 75% of us all agree on something, it doesn't mean they should get their way all the time. It means, like, you should give the other 25% a chance every so often, all right? This is actually a big thing that people have noticed as a weakness about democracies in general, and this is something that people were very concerned about, the people who created the United States. There's a name for this. This is called the tyranny of the majority. And the idea, the sort of like John Adams, Ben Franklin types, they actually thought a lot about this, and they were very concerned about this in terms of doing democracy in real life. This was a problem that they were trying to avoid, the tyranny of the majority. And the idea here is, in a traditional, I will say, what this tyranny of the majority means, with traditional voting, that is not random, but you just count the votes, traditional voting, if some idea gets, say, 51% support, then they will win every time, which screws the other 49%, right? And this is what they call the tyranny of the majority. And so a lot of those old school, people who created the Constitution and such, they were very worried about this kind of a thing happening in our society, and they wanted to create a democracy in which there was ordinary voting, of course, but there were also sort of weird systems that would make it so that even people with only minority support, they could sometimes have their ideas work out in society. And that's why we have, it's one of the reasons why we have things like the Electoral College, which is a weird overlay on top of our ordinary voting that changes the numbers a little bit. And we also have something like we have the House of Representatives, in which the representatives are assigned based on population, but we also have the Senate, in which every state just gets 2 senators regardless of the populations. These kinds of things were set up in order to disrupt the tyranny of the majority. They wanted to make it so that not every decision is decided by the majority, because in that case, the majority is just going to screw over everybody else all the time, and you'll get stuck in certain systems, right? Okay, and that's the point of these random systems. So I would say this kind of random dictator method works great. I would say the ideal situation where you would want to use this is for, I would say, repeated low stakes decision making. If you're going to make the same decision over and over again, and each individual decision doesn't really matter all that much. Like, for example, I would say, here's a made-up example. Me and my 2 roommates decide every night which pizza to get. Let's say we get pizza every night. I don't recommend it. Me and my 2 roommates decide every night which pizza to get, and let's say that I like mushrooms. They like pepperoni. Right? Now, if we actually vote every time and actually count up the votes, I get screwed every time because there's 2 of them and only 1 of me. And this is not very fair. It's fair if I get screwed maybe a third of the time. That would be fair. All right? And so a good alternative, I would say here, just to make this clear, traditional voting if you just vote every time, you're going to get the same result every time, and that result would be they win every time, which is not terribly fair. But if we do this random ballot thing, I win a third of the time, which is better. More fair, in my opinion. Right? That's the point of this kind of a random ballot. It's a weird thing, and as far as I know, this is not used in politics, because politics is fairly high stakes individual choices. But it works great in, this is what I said before there, at the top there, repeated low stakes decisions. If you're doing it over and over again, then the probabilities have time to kind of work out in the long run. And low stakes, just because you don't want a super important decision to be made at random, probably. All right, any thoughts about that? This is the random ballot or random dictator method. It's good for certain things. I wouldn't use it to elect the president, but I would use it maybe to, decide where to go to dinner or something. All right, great. Let's talk about one other. So that was the random dictator, which is one of the things on the list. I got one other sort of quick and easy one to discuss. And this one has a near and dear place in my heart. This is called approval voting. All right. Approval voting. So this is another kind of system. This one has some kind of significance to me because, well, I'll tell you a little story about approval voting in my own ordinary life. But the way that approval voting is, the way that it works is everybody, as usual, is trying to vote between several different alternatives. And in this system, voters don't rank choices. Voters don't rank choices. They only say which options they approve of. Approve, I wrote. Approve. It's called approval voting. They only say which options they approve of. So what I mean by that is a typical ballot, if you're doing approval voting, a typical ballot looks like, I have like A, B, C. Now, if you're doing something like the ranked choice, the instruction to the voter would be to rank them in order. But in approval voting, you don't rank them in order. You only say which ones I approve of and which ones I disapprove of. And the voter will do something like check and check. This is what a typical ballot would look like. All right, so it's not ranking. You're not asking the voters in order who you like the best or whatever. It's just which ones do you like, which ones do you not like. All right, so this means if you see, so this person, if they voted in that way, this person likes B and D, and they don't like A and C. And there is no opportunity to say I like B better than D or anything like that. You don't ask the voters who they like better. All right. And then how do you decide who wins? You just count up all of the check marks. So the winner. Well, to figure out the winner, there's no funny business here. You just count up all of the approvals, and the most approvals wins the election. All right, this is called approval voting. It's like plurality in that, in plurality, you only make one choice. In approval voting, it's like that, but you can just it's like you can vote for more than one if you want. All right. Great. For example, let's just do a typical example here. These are not difficult, but you have to write these examples like in a chart like we usually do for the rank, but it looks different because these are not rankings. But a typical election would be something like, here's my candidates, A, B, C, D, and then I have something like 23 people, they like A and B. So this means there are 23 voters who checked off A and B on their ballot, and maybe there's 37 voters who checked off A and C, and maybe there's 4 who only did, sorry, I meant D. It doesn't really matter about it just because I have these numbers worked out ahead of time. A and C, 37 people vote for A and D. Let's say 4 people vote only for C. Of course, you're allowed to just vote for one if you want. 17 vote in this way. Let's say 21. I'm just trying to give a somewhat complicated example. 3 people approve of everybody. You're allowed to just vote for everybody if you want to, although it doesn't really, that has no effect on the outcome of the election if you vote for everybody. Let's say there's 5 people who vote for nobody, and then 7 people who vote only for B. All right? You are allowed to vote for everybody, and you are allowed to vote for nobody. Although both of those votes don't actually have any effect. Certainly, if you vote for nobody, then your vote just doesn't contribute anything to the totals when you add up all the scores. And if you vote for everybody, your vote contributes equally to all of the candidates, and so again, it doesn't affect the result. But anyway, who wins in this election? You have to add them up. So who wins is the results you just count up how many people approved of A. They are the 23 and also the 37. They approved of A, also the 17 and the 3, right? I'm just looking at all of the voters who approved of A on their ballot. And if you add these up, I added these up ahead of time, I got 80 for that. All right, and so on. This is fairly simple to do once you know what you're doing. So how many people approved of B? That would be here, 23, here, 21, 3, and 7. Those are all the approvals for B. So that's 23, 21, 3, and 7. And those add up to 54. When I do the approvals for C, it's a 4, 17, and 3. C didn't do so great. This is 24 for C. And D gets 37, 21, and 3, which is 61. All right? So those are the results of this approval election. And the winner is 80, so A wins. All right? This is called approval voting. It is not technically a ranked voting system because the voters are not ranking their choices. They're just saying who they approve of. All right? Great. So this, in real life, this is used sometimes. So this is used, one setting in which I know this is used to elect the Pope. You know, when the Pope dies, or they have a little election, and apparently the way that they do the election is by approval. They have a certain amount of candidates. I don't know how they choose the candidates, but they make up little, golden ballots or whatever, and you sort of check off your choices. But when they vote, they don't just choose one person from the ballot. They can choose as many as they like, and then they count up the votes in that way. Used to elect the Pope. I believe that this is also how they choose. I've heard that this is how they choose the winners of like the Oscars. They do something like they have ballots that people vote on, but you're allowed to. The ballot is not just choose your favorite. You can just vote for as many options as you like that you think should win. Right? Even though there's only one winner, you can still vote for several of the choices. And this is also, here's my cute little personal story about approval voting. This is also used to do elections among the Fairfield University faculty. It's true. And here's my personal story. When I first came here to the university, we have like faculty committees on things. Like there's, for instance, if somebody wants to create a new course or a new major or something, like they have to write a little proposal, and then that new course is approved by a committee. There's a curriculum committee, there's like a committee about the library, there's a committee for athletics, there's all kinds of different faculty committees. And we have elections to decide who should be on these committees. And when I got to Fairfield University, we used the plurality system for all of these elections. And I was dumbfounded. I thought, this is the stupidest thing to use the plurality system on. Why it's, in my opinion, like plurality system works fine if there's only 2 candidates. But if there's 3 or 4, many different candidates, plurality system does a pretty poor job. And the way that these faculty elections work is you typically get a list of maybe like 10 candidates, and they're just other professors. And me, like I tend to stick to myself, like socially speaking, on campus. Not everybody knows me, and I don't know a whole lot of other professors. So I get one of these ballots. There's 10 choices. Who do you think should be on the library committee? First of all, I only barely care at all about this election, but I also don't know any of these people on the list. Maybe I know 1 or 2 of them, and so I'm probably just gonna like vote for my friends or something. I mean, it's like a president of the high school or something. It's probably similar to this. But usually I get a ballot where I don't know very much of anything about these. If you give me 10 choices and say I can only choose 1, I'm going to make a very poorly informed decision. If instead you tell me you can vote for as many people as you like on the list, then this is a much better system in my opinion. So anyway, after I came, maybe like 3 or 4 years after I came, I led a major effort and changed the voting system that the faculty uses to approval voting. So if you ever, like I said, not everybody, all your professors probably don't know me, but if you, for some reason, are talking to somebody else on campus about me, you can say, oh yeah, he's that approval voting guy. Like that was sort of like what I was known for around campus, as changing the system to approval voting. And when I, for instance, when I applied for tenure here, you have to sort of demonstrate that your teaching has been good, and also you got to say something about how you have impacted the institution for the better. I was the approval voting guy. That's what got me in. It's better than the plurality system, especially if you have more than 2 options on the ballot. I had to have a bunch of conversations with other professors to convince them that approval voting was a good system. But in my opinion, it is a good system. Any thoughts about that? One person I was talking to, I said, I don't think we should vote in the way that we do. We should let people make more than one choice on the ballot. And she was like, that's stupid. You can't have people choose more than one. And I said, well, yeah, you can. And it's not stupid. This is a weird, it seems weird to let people vote for more than one. But really, if the more you think about it, you will realize there's no reason why that system is stupid. All right, this is my opinion. All right, great. It looks like nobody has opinions at the moment. I think this is the end of our sort of discussion of different voting systems. This was the first kind of major block of content for the course. And if you look on your little checklist, this was like the end of the first big block of topics. And what we're going to talk about for the next couple weeks, that was actually probably the longest of the major units that we're going to do. The other ones will be a little shorter. But I want to talk briefly meaning like for a couple weeks or so, about weighted voting. This is our next major thing to discuss. So we are done talking about these ranked voting systems. If you were getting tired of that, it's behind us now, although you still got to do it on the tests. Our weighted voting is the next big unit here. And this is something that applies to the Electoral College. The Electoral College is something that I haven't talked much about because it's not really, it doesn't neatly fit into any of the voting systems that we've discussed so far. But weighted voting, I will say the Electoral College is an example of this. And there are many other examples in the real world, but the Electoral College is maybe the most famous one in our politics, is an example of a weighted voting system. This is a system involving usually kind of a small number of voters or entities or whatever. A system involving voters whose votes count for different amounts. Voters whose votes count for different amounts. And those amounts are referred to as the weights. So these amounts are called the weights. All right, and a system like that is called a weighted voting system. That is, it's a bunch of people or entities or whatever voting to make a decision, but when you count up the votes, they count for different amounts. So I could imagine, say, trying to do a vote in this class in a weighted way. I could say, let's vote about, should we have homeworks anymore? But my vote's going to count for 20. That's a weighted system in which you all count for 1, but I count for 20. And that's called, my weight in that case would be 20, and your weight, all of you, individually would have weight 1. And this is the way that the Electoral College works. I hope you know. The Electoral College, the idea is each of the states individually has their own little election, and then those states, depending on who wins each of the states, those get added up with weights according to the populations of the state. So for example, the state of California is the biggest, and California gets 54 votes in the Electoral College. I looked up these numbers. The next one is Texas, and these are by population, of course, more or less. Texas gets 40 votes. The next one is Florida, gets 30. I'm not going to write them all. New York gets 28. Florida gets 30. Etc. All the way down to the smallest states, like Delaware, by population, the smallest state gets 3 votes. That's the minimum you can get as a state in the Electoral College. So the rule in the Constitution is that every state gets, this number of votes is determined by the number of senators plus the number of representatives in the House of Representatives in the Congress. And every state gets 2 senators plus representatives based on your population. So the smallest you could ever get would be 2 plus 1, which is 3. California gets 54. That's 2 senators plus 52 for their population, and so on. Right? This is how the Electoral College works, and the way to decide who becomes the president is not by counting up the individual people's votes, but you count up the people's votes state by state, and then you add up these numbers, and that's how you determine the president. It's a weird system, which people have plenty of hot takes about. I personally am kind of an Electoral College hater, but we don't need to debate about the Electoral College. It is a weighted voting system where these numbers here, these are the weights. Right. In our politics, we don't call them weights. We call them, I don't know, electoral votes or something. But in the way that we're going to talk about weighted voting, they're going to be called the weights. All right. And these systems are actually surprisingly weird and interesting. So let's talk about some technicalities, some details, terminology, and then we'll eventually talk some more about the Electoral College. But basically, one of these systems, in one of these systems, each voter, like I've said, has a weight, which determines how many. How much their vote counts for, and there I wrote is twice. There is a quota. These are the two sort of important quantities. Each voter has a weight, and there is also a quota. This is the threshold or the amount needed to win. All right, that's called the quota. So in the Electoral College, there's a certain number. Does anyone know how many electoral votes do you need to win to become the president? It's like 270, something like that. But anyway, 275, something like that. That's the quota, right? There's a certain amount of votes that you need to win. That's called the quota. And this quota, generally, like in the case of the Electoral College, the quota is just 50% or 50% plus 1. You need more than 50% of the electoral votes. So I will say this quota is often, something like 51% of all the weights. But sometimes it's not. Like there are certain situations in politics or just in life in general where, in order to pass a certain law, you need a 2/3 majority or something like that. Those situations do exist in our politics. So this quota is often 51% of all the weights, but sometimes it's different. Sometimes more, right? Sometimes there are certain things where you need to get 2/3 or 3/4 of the majority, something like that. So the quota is not always just 50%. All right? We got about 15 minutes. I want to try to convince you that there are weird and interesting sort of mathematical effects of this. So the math of these systems is sometimes weird. And I would like to give you an example here. Let's have an example in which, let's say there are 5 voters with weights like so. They are 12, 10, 5, 1, and 1. And let's say they're voting about something, and I don't really care what it is. Let's just say they're voting to pass a law or something. All of this, when we talk about these weighted voting systems, we're always going to assume that they're just sort of voting on like a yes or no question. So like if they want to ban vaping or something. So they are voting on a yes or no question. And let's say the quota of 20 votes. That means in order to get to a yes, you need 20 of total votes in order to actually pass the law or whatever, all right? You need 20 votes. And I would like to, so the basic question that we're always going to be asking about this kind of a system, this is a weighted voting system, is who has the power and how much? That's the very basic question that we always want to answer in such a system. Who has the power and how much of the power do they have? All right? And you can tell by looking at the numbers of the weights. All right? So here, I'm going to write this in red because it turns out I'm being a little sneaky here for reasons which you will see soon enough. So I will say, it looks like 12 has the most power, right? Because their weight is the most. The 10 has a little bit less, right? Because, of course, 10 is a little bit less than 12. The 5 has, like, quite a bit less. 5 has, a lot less. And then the 1 and the 1, so there's 2 people with only 1 vote. They have, like, very, very little amount of power. Have only a little power. Because their vote only counts for 1 compared to 12, from that other guy. All right? This I wrote in red because this is actually not really accurate, what I said there. And this is what I said. The math of this can be, what did I say? The math of these systems is sometimes weird. Just looking at the numbers, it would seem that the 12 has a little bit more power than the 10. And then the 10 has a lot more than the 5, and then the 1 and the 1 have very little power. Does anybody see something that's actually, this is not correct. What's in the box there is not quite accurate. Anyone have an opinion about this? It has to do with the quota. The quota is 20, all right? So in order to make it to, pass the law or whatever, you have to get to 20. Anybody feel anything about this? We got 11 minutes remaining. We can have a little chat. How about this? I know I don't often do this. Would you take, can I give you like 3 or 4 minutes? Turn to your neighbor, chat with your neighbors about this. Something is wrong about what I said in the box. I would like to give you a few minutes to decide, see if you can come up with anything. Are you ready to chat with your neighbors? I'll be honest, when I'm like in a room like this, I don't want to chat with my neighbors. Usually I just want to sit there, listen, maybe say something every so often, but do it. Chat with your neighbors. See what you got. Something about this is not quite right. The 20 is important. That's my hint. What are the various ways these people can make it to 20? Oh, you're just going to be adding them up. I give you 1 more minute, and then we can chat about it. All right, can we chat about it? I heard some great comments. I was eavesdropping a little bit, and then about a minute ago, it seems like you started talking about other things, which is fine. Anybody? Would anyone like to share? Yeah.
Because you need 20, and the total together is 29. So if the 12 voted differently than the rest, it still wouldn't equal the 20. So you can't get the quota that you would need regardless. You would need the 12 and the 10 to vote together at least.
Yes, this is the key insight. I would say the only way you can make it to 20 here is if the 12 and the 10 both agree, right? You cannot, these other guys, 5 and 1 and 1, they only add up to 7. And so they by themselves can't make it to 20. And in fact, even more, even with the 10 and the 5 and the 1 and the 1, they can't make it to 20, right? The only way to get to 20 is by using the 12 and the 10. So this, I would say the quota can only be reached if the 12 and the 10 both agree, right? Now, it says in the box, 12 has the most power, 10 has a little bit less. I think actually this is not true. I would say because you can only make it to 20 if the 12 and the 10 are together. I would say in this system, the 12 does not have any more power than the 10. They have to both go together. And if either one of them is out, then you don't make it to the quota, all right? In this system, there actually is no difference between the 12 and the 10 because there's no scenario in which the 12 can add up to 20 in any different way unless it's with the 10. So the quota can only be reached if the 12 and the 10 both agree. And in this case, the 12 actually has the same amount of power as the 10. Even though obviously 12 is more than 10, but just because of the way these numbers can combine together, there is no additional benefit to having the 12 votes rather than just the 10, because you still need both of them together. And then what about everybody else? So here, what it says in the box is Looks like the 12 has the most power, the 10 has a little bit less. This is not true. The 12 and the 10 are equal in this case. And then what about the other ones? 5 and the 1 and the 1. How much power would you say they have? I would say they have no power at all. There is no way that those numbers could ever contribute to making it to 20 or not making it to 20. All right? Just because of the way these numbers add together. The 12 has the same amount of power as the 10, and the 5, 1, and the 1 all have no power at all. This is not obvious. You have to think closely about these numbers and all the different ways that they can add up, but just so it's still on the screen. 12, 10, 5, 1, 1. Right? It is not true that the 5 has more power than the 1s in this case, because you're trying to add up to 20, and these guys here just never matter at all when it comes to adding up to 20 in this particular system here. All right? This is the weirdness that I want to talk about. Like, for example, in the Electoral College, you know, I said like California gets 48 and Texas gets whatever. Was it 48? I don't remember the numbers. California gets 54 and Texas gets 40. But that does not necessarily mean that actually California is more important than Texas. Maybe they are of equal importance because of this weird business. And maybe Delaware gets only 3, but maybe actually in reality Delaware has no power at all in the system. These are things that need further analysis and study. All right. So this is kind of the basics of what all of this weighted voting will be. Is sort of how exactly. You know, this business involved like chatting with your friends about it, but if you really wanted to do this for real, how exactly can we measure each voter's power? Right? And it's not obvious just by looking at the numbers. Like in this example, these numbers, the actual power that each of these voters have is something like this. The 12 and the 10 are equally powerful, and everybody else is totally irrelevant, right? So if you were trying to measure the power, the true relationships of the power here, they are this. 50% of the power is here, 50% is here, and these guys are 0%. But how exactly do you figure out these percentages based on those numbers? That's a very complicated thing, and that, you know, not too complicated for us, but that's what we're going to be talking about over the next little while. All right, I think that'll do. I didn't